Hi everyone, and welcome to the Intuition Lecture for Linear Discriminant Analysis, or LDA. Now, for those of you who are coming from the previous section on Principal Component Analysis, or PCA, this may seem a bit similar, but there is a difference between the two, and we're going to get started by taking a look at overall what LDA entails. It's a pretty brief and straightforward intuition lecture, but we'll get to the main takeaways between PCA and LDA. LDA is commonly used as a dimensionality reduction technique, and we've heard that before with PCA. It's used in the pre-processing step for pattern classification and machine learning algorithms, and its goal is to project a dataset onto a lower dimensional space. Sounds similar to PCA, but LDA differs because in addition to finding the component axes with LDA, we are interested in the axes that maximize the separation between multiple classes, and that is the main takeaway, or the main point, is where PCA we are with that distinction and working with the principal component analysis with the axes, the principal components within the data, but whereas we're looking in LDA, we are looking for the separation of those classes within the data. And to break it down further, the goal of LDA is to project a feature space onto a small subspace while maintaining the class discriminatory information. And we have both PCA and LDA as linear transformation techniques used for dimensionality reduction. PCA is an unsupervised algorithm, but LDA is supervised because of the relation to the dependent variable. And we can see here from this visualization the main operations and main differences between PCA and LDA. PCA, again, we're looking in that subspace and the dimensionality reduction technique of the data to examine how the principal component axes are in relation, whereas in LDA, we're looking for that class separation. And I think this visualization kind of makes it the most clear between the two. If you want some additional information, you can always take a look at the following link. But here we have the PCA and LDA and the main operations related to each. Again, LDA supervised because of the relation to the dependent variable. And I think when you start working through this in the upcoming lecture and the hands-on part, it's going to make more sense. But that's the main takeaway, to focus on LDA. And you can accomplish this by 5 main steps, similar again to PCA. The 5 main steps for LDA include the following: the computation of the d-dimensional mean vectors, the computation of the scatter matrices. You have to also compute the eigenvectors, sort the eigenvectors by decreasing eigenvalues, and use the d times k eigenvector matrix to transform the samples onto the new subspace. Overall, very similar to PCA, 2 different types of dimensionality reduction techniques, one being unsupervised and one being supervised, but the main distinction with LDA to take away is that we're looking for that class separation within the data. Overall, if you're coming from PCA, this should seem familiar for the majority of operations. If you're new to this, I advise you to go take a look at PCA as well. But when you are starting to work through the next upcoming part, it should make more sense. But just keep in mind that the main takeaway for LDA is that class separation, and it is a supervised learning technique. If you have any questions, as always, please feel free to share them, and enjoy machine learning.